Now the next topic is inverse Laplace transform of derivatives. Statement: if L inverse of f bar of s equal to f of t, then L inverse of nth derivative of f bar of s, means I am writing here f bar of power n s, means that you have to understand nth derivative of f bar of s, that equal to minus 1 whole to the power of n t power n f of t, where nth derivative of f bar of s is d power n by ds power n f bar of s. This is the formula. Now when should I apply this one? Means suppose if the function containing log, tan inverse, cot inverse, then you should use inverse Laplace transform of derivatives. By using this concept, we will calculate the inverse Laplace transform of log of some function in terms of s, tan inverse of in terms of s. Then we can apply this technique. Now let me solve one problem. Find the inverse Laplace transform of log of 1 plus 1 by s square. Observe this one. This f bar of s they have given in terms of log of 1 plus 1 by s square. Then if you observed log, tan inverse, cot inverse, then you should apply this type of technique. Now f bar of s equal to log 1 plus 1 by s square. This can be written as log of s square plus 1 by s square by taking LCM. Log 1 plus s square minus log s square. Then this can be written as log a by b formula. Okay, according to that one we have written log 1 plus s square minus 2 log s. Now this is our f bar of s. I modified this f bar of s, the given f bar of s. Now first derivative of f bar of s. First derivative of f bar of s is 1 by s square plus 1 into 2s. Again minus 2 by s. This can be written as 2 by 2 is outside, I have taken 2 common, s by 1 plus s square minus 1 by s. Now L inverse of first derivative of f bar of s. Now already I gave you L inverse of first derivative of f bar of s. First derivative L inverse 2 into L inverse of s by 1 plus s square minus L inverse of 1 by s. The answer is minus 1 whole to the power of 1, n equal to 1, t to the power of 1, L inverse of f bar of s equal to 2 cos t minus 1. Then L inverse of f bar of s equal to, just you send that side, then what will happen? 2 by t 1 minus cos t. I have taken minus common, minus into minus is, it becomes plus. Therefore L inverse of f bar of s means L inverse of log 1 plus 1 by s square. The answer is 2 by t 1 minus cos t. This is the answer. Like this, log, if you have observed log, then like this we can solve the problem. Now let me solve one problem in terms of cot or tan inverse. Find inverse Laplace transform of cot inverse s. Now again let f bar of s equal to cot inverse s. Then first derivative of f bar of s, d by ds of cot inverse s is minus 1 by 1 plus s square. Now L inverse of first derivative of f bar of s is minus 1 t into f of t. Then L inverse of f of t is nothing but L inverse of f bar of s minus 1 by t. L inverse of first derivative of f bar of s, first derivative of f bar of s is minus 1 by s square plus 1. 1 by t into L inverse of 1 by 1 plus s square. The answer is 1 by t into sin t. Now L inverse of f bar of s is L inverse of cot inverse of s. Like this, sin t by t, this is the answer. Now from first derivative you have to calculate of f bar of s. Mostly we will get the tan inverse and cot inverse of s. Now inverse Laplace transform of integrals. Inverse Laplace transform of integrals is, the formula statement of this concept is, if L inverse of f bar of s equal to f of t, then L inverse of integral s to infinity f bar of s ds is f of t by t. The same concept we are applying that inverse, all those things from the Laplace transform of integrals. From that topic we are getting like this: inverse Laplace transform of integrals. Once again, L inverse of integral s to infinity f bar of s ds equal to f of t by t.